Yeah, hello. My name is Felix Weinrank. I will present you the integration of the RTMFP model in the OMNeT simulation environment. And briefly the outline. First, an introduction to the RTMFP model, because what is RTMFP and what are the key features of RTMFP, OMNeT and the OMNeT model and its architecture, validation, how to validate the model, and our ongoing work. So first, a short overview. RTMFP is an acronym for Real-Time Media Flow Protocol, and it has been developed by Adobe Systems. And it has been integrated into the Adobe Flash Player since 2008 at version 10, and also in Adobe Air, which is distributed to Android devices, for example. And its purpose is for peer-to-peer audio and video communication. In the real world, some implementations or some applications which are using RTMFP are popular now. For example, chat roulette was one of the well-known applications. And in 2013, Adobe published an informational RFC, and where they describe how the protocol itself works. And in 2014, they published another informational RFC where they give more information about crypto and how some questions came up with this RFC, so they published another one. The key features. First, it's message orientated, which means it's usually uses UDP. It's encrypted. It's using a four-way handshake to don't be vulnerable to denial of service attacks. It uses net reversal. It's capable of multiplexing. The keywords are sessions and flows. We will see on the next slide what this means. Hypermobility, and this were especially in our focus. It has a TCP-friendly congestion control per session and a flow control per flow. So, what does it mean, session and flows? When I establish a connection to some of you, to a peer, like for example Michael, we have a session. And the session is identified by a unique session identifier. And within the session, there are flows. Flows are just capable of one direction, and each flow is prioritized for the content which is transferred by the flow. For example, audio is over video, is over data. So it's a multi-purpose protocol which can transfer whatever you like. So we took the RFC and we built our model in OMNeT INET, and this is our architecture. We here have the UDP layer, and on top of the layer we have the UDP, and on top we have the RTMFP layer, where all the logic of the protocol is implemented. For example, connection establishment, session handling, flow handling, all the queues. And we have applications, RTMFP apps. How many you like? There's currently we are supporting, I've tested with 128 and it works. So every application is using the single RTMFP layer, like a normal protocol, to another layer, and we use the applications as traffic generators. You will see in the next slide why.
This stack is for control or for the data?
Which one?
What you show here is for the control of the protocol?
No, it's, this is the architecture where how the protocol is, how to say, the logic of the RTMFP protocol, which is described in the RFC, is here. And we have applications which use the RTMFP protocol, and they are connected via gates. Does this fit your question?
Okay, later.
Okay. So the features we realized is the four-way handshake, the flow control, the congestion control, multiplexing, and bundling. And some features we have not realized yet, for example, encryption, net traversal, and IP mobility, because they were not in our focus. And we validated the model with some methods like the bandwidth delay product. We validated for packet loss, fairness to within the we compared several RTMFP flows and fairness to SCTP flows. It was really hard to validate the model against commercial to real implementation, because they are all commercial. You have to buy the Adobe Flash suite to create RTMFP applications. And this is really, really hard to compare the model to these implementations. Why we use SCTP flows? This is because in our laboratory we also developed the SCTP model for OMNeT INET, so we have some knowledge in this this model and we are familiar with it. And it's TCP. It has a TCP-friendly congestion control, which RTMFP also has. They mentioned they have, and we tested. This is an example of how we validated the model. For example, we have two RTMFP clients and a background traffic generator, which generates random UDP packet. We have a bottleneck scenario. We have RTMFP servers, which receive messages from the RTMFP clients. And here we have a situation with a 1 megabit bottleneck link. And here we see the two comparing RTMFP peers, red and blue. And you see it's nearly, they nearly share the bandwidth pair. We have some effects that depends a bit on the parameters, the congestion control and the routers. And here, this is a comparison of an SCTP flow and an an SCTP transfer and an RTMFP transfer. Here, the red line shows the RTMFP transfer, and at this point, the SCTP client starts sending, and you see nearly same bandwidth. So we can say RTMFP is nearly TCP friendly in comparison to SCTP. So our ongoing and future work, this is the main why we implemented the RTMFP model. We are interested in comparing RTMFP with WebRTC, because SCTP is used in the WebRTC stack, and some other techniques are used in WebRTC, and RTMFP is the protocol one for all. In WebRTC, we are using SCTP just for data channels, and with RTMFP, it would be possible to transfer all data, audio, and video. And we are focusing on the congestion controls. And currently we're building generic traffic generators to compare RTMFP with WebRTC. This is a cooperation with our university and the University of Duisburg-Essen, where they are building a model for RTP to nearly cover the WebRTC stack. So, conclusion. We have realized major features of RTMFP RFC. The congestion control is nearly TCP friendly. We have still some work and research to do, and we will publish the sources on GitHub as soon as we have fixed some bugs we currently have with the current OMNeT INET versions. And we are doing some work on the models would take some time. This was some questions in the reviewers mail. We will publish. It will take some time. Thank you.
Thank you. So, first of all, are there any questions? There are questions.
I think I have like two questions. The first is when you have the picture of the design, the current design, there's this compound module where the app and the layer is integrated directly.
Yep.
But if you're like developing something for standard INET, why not stick to the standard INET scheme and put your transport layer protocol where it belongs and put your applications where it belongs?
Yeah.
Why put it in a compound module?
Because when I built this architecture, it was my first model in OMNeT INET. So it was at the very beginning, and I didn't knew better. So I will fix this. It's the current status of the model.
Yeah. So and then coming back to the RTMFP application,
Yeah.
and the question of the traffic generators that you're addressing in the future work.
Yeah.
So what kind of specifics does your traffic generator need? What kind of traffic is specific for RTMFP?
We are building, we have a very generic traffic generator where we just say, okay, start at second 1, send 1,000 packets with maybe every 10 milliseconds, or very simple one. And then on top of this generic generator, we are building more complex one. Like we are currently building a traffic generator where we extract information from a real video stream and inject them. So to get as close as possible to real video streams, for example. And so we take one RTMFP application for a video stream, we take another one for audio, and a third one for data, for example. Does this cover your question?
Mm-hmm. I think there are some overlapping points with the final tutorial that we have with the multimedia wireless sensor networks, because they also have video transmissions, and you can see directly the effects that the transmission protocol has on the video. Yeah. There might be some existing work that you can leverage on. Also from other frameworks, I think there was a framework where video transmission and the effects on video transmission is also covered for wired networks.
Yeah.
Any other questions? Comments? I was wondering, could you expand a little bit on the aspect of model validation? Because that seems to me that might have been the hardest part in getting this to work right.
Yeah.
Especially with closed source implementations to compare with.
Yeah, it was quite hard for me and for us to get the validation, because we had just several scenarios where we focus on the focus for the protocol was the congestion flow control, flow protocol control, especially the congestion control. So we built several scenarios. This is only one. We built several scenarios with some amount of clients, of concurrent sessions, of concurrent flows. Yeah, but it is really hard to say, okay, this covers exactly the RFC.
So what did you do? Carve out a random subset?
No.
It sounds very hard.
Yeah, for example, we took the bandwidth delay product, and I don't know. I have to tell what exactly we do. Loss-based. Yeah, we compared especially with SCTP. And looked at the congestion control is fair.
I see. Okay.
Not very.
It might still have been terribly hard. I have no idea when to start dealing with that.
So did you implement the congestion control by yourself, or you took this module from?
No, it's implemented because the RFC is quite detailed how to realize the congestion control. We need a congestion control because we are UDP based. So we've taken, and there's example code in the in the RFC. So we implemented the congestion control inside of the model.
Does that answer the question?
Yeah.
Anders.
So, how does this protocol handle packet losses? Are they retransmitted or just allowed to be lost? And is there a tool? Question: is there a tool to see how, like, packet jitters and lost packets affect like video quality?
First, the transport protocol is reliable. You may drop packet, you may be unreliable, but in default it's reliable. So it uses X, and it X every other packet. Yeah, there is a channel up to the application, for example, when there's loss, to reduce the rate. It's not especially mentioned, but in the RFC it says, okay, there should be, the application should be informed about packets.
So this is not really a real-time protocol, because there is contradiction between being real-time and congestion control.
This is what you get when you use a flash player for communication.
I mean, it is
Flash is
real-time.
not real-time. No, yeah.
They do audio-video conferencing about it.
Depends on
Yeah,
the number
it depends
of
what is real-time. I mean,
Sure.
You
Yeah,
have
it's-
a delay of 10 seconds if this is real-time, so this is fine.
It's what Adobe do. I mean,
It's Adobe's impression of real time. Let's leave it at that. Other comments? Okay, then thanks again.